Wonderful. Well, welcome everyone, and welcome to my guests, Peggy Clouston and Alex Schreier, both from UMass Amherst, and everyone joining today at MassCEC and beyond to Thoughtful Climate, our speaker series. Here each month, we'll highlight experts, pioneers, and practitioners from a variety of existing and emerging climate tech sectors and disciplines, as well as subject matter experts who can provide insights into broader economic, social, and technological dynamics shaping the climate tech industry. Today, we're talking about mass timber, its promise as a low carbon building material, its potential as a rural economic driver, and a promising solution to the region's affordable housing challenge. We'll also discuss some of the market traction challenges facing mass timber and steps that must be taken to ensure that mass timber products contribute rather than detract from our climate objectives. Before I jump to Peggy and Alex, I'm going to provide a bit of context for our conversation today. In our industry and discussions about reducing carbon in the built environment, we tend to focus a lot of our attention on so-called operational carbon, the emissions associated with energy consumed either at generating facilities to power our grid or on-site in buildings in boilers, hot water heaters, or stoves. Less attention is paid to embodied carbon, the emissions associated with the resource extraction, manufacturing, delivery, and installation of building materials. And as our buildings become more and more efficient, thanks to more and more stringent building codes, the share of embodied carbon relative to operational carbon is increasing. And that is why more and more attention is being paid to the embodied carbon in building materials, particularly those that are energy intensive to produce, like steel and concrete. Of course, we build low to mid-rise residential and commercial buildings in this country with conventional wood products, so-called stick-built construction with dimensional lumber like 2x4s and 2x6s and sheet goods like plywood. So what is mass timber and why might it be a superior alternative to both conventional wood products and other framing materials? So this is a huge topic, a sprawling topic, and I know that we won't have time to touch every angle today with Peggy and Alex, but we'll do our best. So let's dive in. A bit of housekeeping before we start. As usual, if those of you who are listening in, feel free to drop questions in the Q&A, and we'll reserve some time at the end of our conversation and do our best to address those. But Peggy and Alex, I really appreciate you joining me today, and happy Halloween.
Same to you.
Yeah, thank
Same.
you. None of us are in costume, but that's okay. So please take a moment to both introduce yourselves. And Peggy, why don't we start with you? I remember hearing about your research several years ago. I know you're exploring, in part, the potential for regional tree species, including hemlock, to provide feedstock for mass timber products. And I was really intrigued and excited by that. So just love to hear more about your background.
Okay. Um, Hi, everybody, and happy Halloween to everyone listening. So I'm a professor of wood mechanics and timber engineering at UMass. I actually started out as a structural engineer in Vancouver back in the early 90s. I was designing timber structures in Vancouver and the environment around there. I did all three of my degrees at UBC, and then in 2001, I was asked to join UMass and mostly do research on wood, but it branched, pardon the pun, but it branched out into other directions like bamboo and grass and straw, bale, and a lot of different renewable materials of that sort. Um, Maybe I could hand it over to Alex at this point, and then we'll kind of clue it up.
Great.
Sure, sure, no problem. Hey everybody, happy Friday. Yeah, so I am a senior lecturer at UMass Amherst. I've been here for a while and have been teaching courses in materials and digital design. And my background is also engineering, structural engineering, and I'm also I've done wood research in my background. Currently, I'm a little bit more on the administrative side, so I'm actually this year also the department head of the environmental conservation department at UMass Amherst, which is very relevant to our topic because within our department, we have forestry, and we do have mass timber building products and other things too. We do have fisheries, wildlife, and there's all of these other topics. And as it turns out, forests, very much impact and provide ecosystems for those. So anyway, so that's a little bit of my background right now.
Great. Thanks, Alex. So let's level set. Peggy, could you please just briefly define mass timber so we all know what we're talking about here?
Well, actually, if you wouldn't mind, I just wanted to back up a wee bit because Alex and I have been working on projects together for a long time. And a couple of points of pride that I'd like to kind of set out there in the early stages is that Alex and I were actually the faculty intervention into making the Ulver design building, which is the
Oh, great.
state-of-the-art mass timber structure. We were the reason that it became mass timber. I reached out to, or was lucky enough to get the ear of former Congressman John Ulver, and he saw the environmental benefits and also wanted to help, reinvigorate the local forestry. So it's all very relevant to our conversation today around local species. Um, and made it so. So without him, it wouldn't have happened. So the other point of pride is that Alex and I have a new book coming out on mass timber with Wiley Publishing, and folks can pre-order it on a website, I think, that Galen was going to provide or is going to provide at some point. So
Wonderful.
yeah, back to what mass timber is exactly, your question. It refers to a group of engineered wood products that are large enough to be considered heavy timber by the building code. Products like glulam, cross-laminated timber, dowel laminated timber, structural composite lumber. Some of these terms you may or may not know, but they're basically made from gluing together smaller parts of wood, usually 2x4s or smaller, and making them into much, much larger pieces that are then used to frame floors and walls and beams and columns and that kind of thing. Um, their sizes are so big that they're used typically in large-scale construction alongside steel and concrete. So not necessarily intended for single family housing type applications.
Great, wonderful, and I think thank you for dropping the link into the overbuilding. It really is beautiful. If you're from the state or from the region, I strongly recommend a visit. It's wonderful to see this building on the UMass Amherst campus. So
I
okay, so
took the
that's
liberty
that's
to change my background. So that
yeah,
is the
Ah,
overbuilding during construction.
yeah, great.
As a bit of
dare,
context.
dare I do this? I'm actually
Oh,
sitting in
wonderful.
my office with some beautiful connection details there. When my students from timber engineering design come up to talk with me, I just point at the building as the example, as the educator actually in the process of this is how connections are made in these state-of-the-art buildings. So it's great.
Sure, that's wonderful. Um, so let's pivot to the benefits, and maybe you can kind of both tag team this one. What are some of the core benefits of mass timber? Peggy, do you want to lead off?
Oh, sure. Um, I would say primarily the reason eyes have been put on mass timber is because of the environmental benefits that you pointed out at the very beginning, Galen. What's commonly recognized is that wood has a low embodied carbon compared to steel and concrete. And as you said, it's like basically turning trees into wood products emits a relatively small amount of carbon dioxide, especially if you compare that to concrete. And you may have heard this phrase out there. I think CBS News published it once. If the cement industry were a country, it would be the third largest emitter of carbon dioxide in the world after the US and China. So in terms of how do we build better and have a smaller environmental footprint, it makes a lot of sense that, wood is one of the materials that we should be looking at. But it, I think, goes way beyond that. Life cycle assessment studies have shown it to have many studies. This is not just one-offs, but many of them now have shown it to have a smaller environmental footprint across all the categories, like lower eutrophication, which is pollution to our lakes, and lower global warming potential, which has other pollutants beside carbon dioxide, nitrous oxide, all kinds of nasty chemicals are reduced by turning trees into wood products. And then besides putting less carbon in the atmosphere when it's produced, it also has a way of taking carbon out of the atmosphere and store it into our buildings for hundreds of years. So um, it's a substantial amount too. I mean, these wood products are 50% carbon by dry weight. So you could even make the argument, and I think I do in the book, that using mass timber in large structures on a global scale could be considered like creating a new carbon pool, like the forests themselves or the oceans that are able to draw down carbon and hold on to it. So to offset our climate crises. I think that's all I had to say about environmental, but another point I think is a main benefit of using mass timber, of course, is the aesthetics and the biophilia. Really not my area of expertise. There are scientists now who are specifically looking into the biological and psychological effects of being surrounded by wood. But I can tell you from personal experience that these large rooms that have surfaces of wood strikes you at kind of an innate, beyond emotional, like beyond the comfort level. It's mood lifting, and people in the building are happy to be here. I mean, we have lots of students who I've just heard recently, showing around their parents, this is not a building I have classes in, but I just like to study here. And it genuinely is like a connection. And the cool thing is
Studies are quite compelling, actually. The studies about the health benefits are quite
reduction of,
compelling. I think there's something else with regard to I think I'm intrigued also by the fact that the some of the MT products serve in many cases, right, as the finish material, right? So you're also eliminating the
exactly.
need for drywall and other finish materials that may have themselves high embodied carbon. You're able to use a structural material as a finish material. So it's also just a more elegant way of constructing
Excellent,
buildings.
excellent point. Because they're considered heavy timber, they don't require the additional fire protective coating like what wood steel would require or light
Mhm.
frame construction would require. Great point. Yeah. So in fact, you can have the end structure as the finished material, and like you say, avoid all that other embodied energy from gypsum board or the nasty spray that they spray in concrete garages or steel that has to be applied to steel so that it doesn't melt during a high temperature situation.
Yeah,
Actually,
absolutely.
from the construction perspective, if I can jump in
Yeah,
just for a
please.
second. I mean, there are a bunch of very practical benefits. One is, of course, well, it's easier to attach anything to wood, right? So you can screw into that. You can drill holes easier after the fact, although most of penetrations and holes and connections are pre-drilled in construction. So there's that. One thing that we noticed on the construction side was it's quieter and everybody seems to be happier. It's not as as loud and inhospitable. Maybe another benefit to mention there is that mass timber is typically pretty much always pre-manufactured. Any kind of mass timber element gets manufactured off-site, not just produced, but also cut to length, drilled, all of the holes, everything is pre-cut. So typically there is no on-site cutting for mass timber building elements, and they just come in, like the crane just pops them into place, and that way also you can increase construction speed because now the fabrication can run in parallel. You don't have to have concrete that needs to harden on the construction site and you got to wait for it and those kind of things. And so there's that benefit. And aesthetics, I think you mentioned that's absolutely a big one. Usually the
Yeah.
first thing that architects kind of gravitate to, of course.
No, that's very helpful, Alex. And I think we will get into this a bit later, but it's also worth noting that and please correct me if this is inaccurate, but a good deal of the mass timber products right now that I think we're seeing installed or being used for construction projects, they're relatively small number, but growing number of construction projects in New England are coming from Quebec. Is that accurate?
Yes, northern Quebec is where Nordic Structures has their facility. So a lot of the wood basket is directly, 7 hours drive north of the border.
Mm.
It's just one of the mass timber facilities. Some of the other structures around here have taken them from the Pacific Northwest mills, or even Europe. In Germany, there's KLH, who's a strong competitor. So the mass timber comes from a lot of different places right now. Hmm.
I wanted to just get into two other, thank you. That was very helpful, I think, for folks to understand some of the core benefits. One that I think is somewhat, it's interesting and not intuitive is the fire resistance. And I was very interested to learn about that. And I suppose if you begin to think about it for more than a few minutes, perhaps it is intuitive because you don't start a campfire with logs, you start it with
Exactly.
kindling. And so in some ways, it makes sense that these large timber products would, would take a long time for them to catch fire. And because of their thickness, um, it will take a long time for fire to begin to impact their structural integrity.
Hmm.
Whereas steel structures can fail in some cases more rapidly. So
Right.
um, I think that's accurate, but please correct me or chime in if that's not. But I always thought that was kind of one of the more interesting benefits of mass timber construction.
Yeah, you're absolutely right. I'll kind of expand on it a little bit more in that I have this great graph that I show my students in the timber engineering class about how high temperatures, ones that are experienced during a fire, affect both wood and steel. So mass timber, as you say, has the ability to char, and that layer around the outside of a large section of wood actually provides an insulative layer and protects the strength of the core of the wood. So the massive sections are able to hold load for easily 2 hours before any kind of structural concern happens. Whereas when steel is exposed to high temperatures within, I'm not going to remember the exact timing, but I think it's like within 20 minutes, the capability of the steel to hold the high load drops. The steel melts and it ultimately gives way. It can't hold the load any further. So safety wise, the mass timber is a far better situation. Nobody wants to deal with a fire after the fact. So of course it's going to be a mess, whether it's steel or concrete or whatever it is. But the safety component, which is what building codes really pay close attention to, mass timber doesn't need to be additionally protected for that reason. Actually,
Yes,
one other
thank you.
thing, this is great image that came out of British Columbia. It was a fire, an aftermath of a fire where the ground, the first floor was framed with parallel strand lumber, which is a mass timber type product. And the second floor was framed with steel. And after the fire, the steel beams from the second floor fell on top of the wood beam from below and melted over like a kind of wet noodle. So it was really a like visual understanding of how the two materials behave in high heat.
That's powerful.
Yeah.
Yeah. Thanks for that, Peggy. That's helpful to understand. So let's actually talk about some of the environmental and ecosystem impacts. I think one of the brilliant moves that this state made years ago was to combine energy and environmental affairs under one cabinet, and we do need to keep our focus squarely on both objectives, advancing our clean energy agenda and moving toward our climate objectives while also protecting our forests, our ecosystems. So I want to make sure that we cover this in depth. Of course, there's no perfect building material. We talked about concrete earlier, and we're blessed with having some wonderful and creative innovators in the state that are working on low embodied carbon concrete, which is great. There's no doubt that low embodied concrete is superior to to the business as usual approach. But for mass timber, it just seems like we need, perhaps among other things, manufacturers to optimize timber harvesting approaches to ensure the lowest possible ecosystem impacts. And that means, thinking about the impacts on our forests, the impacts of using heavy equipment during logging on which can harm the carbon sequestration capacity of our forest soils. So how do we get this right? Because we're already depending on our forests here in the state and around the region, and of course, indeed around the globe, to sequester substantial amounts of carbon if we're to meet our climate objectives. And now, unfortunately, we also there's some new science, new research that shows pretty clearly that the ability of our forests to sequester carbon may um, will likely be negatively impacted by climate change because of rising temperatures. So we have all these pressures on our forests. Um, so I guess I would love you to both just kind of jump in here and talk a bit about timber harvesting, best practices, if we're to grow this industry in our region, how should we do it? How can we do it responsibly? Should we establish EPDs or environmental protection declarations for mass timber products? What should the reference life cycle analyses include? I'd love to have you both kind of address some of those core questions around environmental ecosystem impacts of mass timber. And perhaps, Peggy, you can start.
Okay. Um, I have to start by
And
saying,
sorry, that was a lot.
no, it's totally that you're absolutely right. If we're starting something, we need to give it full thought all the way through, that it would be a smart thing to do. Um, so I don't know a lot about timber harvesting practices because that's not something I study, but I do know that North American protocols from organizations like the Program for Endorsement of Forest Certification and the Forest Stewardship Council and SFI, um, Society for
Sustainable
Forest,
forest, sus-
you know, all of these.
sustainable forest
There it
initiative, I
is,
believe it
Sustainable
is.
Forest Initiative. I just
Gotta
go
get
by
our
the
TLAs
initials.
right.
Those darn acronyms, SFI, FSC, they just rattle off the tongue, but to actually go back. No, they follow really strict protocols that balance ecological, social, and economic factors. And then when lumber is certified by any of these organizations, they make sure that it's guaranteed sustainable, traceable, ethical. They're really like strong eyes on this. So
There's a chain of custody.
the chain of custody is
Yeah.
also very much part of it. Any mass timber manufacturer in North America will have already provided, they're very strong about prominently featuring their certified lumber in their literature. They have green verification reports that's certified by American Plywood Association, APA, and that they have EPDs already conveying the LCA data of their products. That's really like a point of pride for them that all of the wood that they use in the mass timber products come from certified forests. So um, I can't honestly say that we are growing more lumber right now than is being harvested. I do believe that's true, but the difference might have to do with the forest fires that we've been suffering. There's this amazing website called Global Forest Watch, and anybody can go to that site and interactively see how forest cover has changed over the past 20 years. So that we definitely have control over making sure that forests stay as forests in North America because of these really great protocols that are in place, looking after wildlife and ecological diversity and all of the main issues that people have. But because of the stresses from drought and infestation, our trees are susceptible to um, forest fires, and we've seen it in Canada, and there are large swaths of forest devastated, which unfortunately is making climate change even worse because it's putting more CO2 back into the atmosphere. So, you know,
Right.
I would like even more strongly say we need commercial incentives like mass timber to do more forest management along the lines of, best practices, just as you're saying, so that we can even more prevent these forest fires from happening if possible. But yeah.
Maybe
No, that's very helpful,
Yeah, it
Peggy.
costs money to get foresters to, work out um, riparian zones and all of those best practices, which I don't know enough about, but definitely we we need to do more about that, and we need to pay for it. The way to pay for it is to have economic incentives, like cross-laminated timber, for example. So.
Mm-hmm.
maybe if I could just quickly jump in. I mean, one for anybody who's interested in this particular topic and healthy forests, it's actually great to talk to a forester, a person who knows this in and out. And we just recently were on another forest walk with New England Forestry Foundation, great organization from the region here, of course. And it's amazing to hear how mindful they are about forest management. And I mean, this is of course done differently in different parts of the country because of different species, different climate zones, et cetera, et cetera. And then of course, very differently all over the world, like Peggy already alluded to. Um, but it's very interesting to hear the thought process that go into forest management, where what may look like a clear cut to the untrained eye, what may look like brush left on the ground to the untrained eye may actually be a habitat, may actually be helping future forest growth, and different forests have different ways to regenerate. So our forests here have very different ways to regenerate than the Pacific Northwest, for example, or some other places, of course. And so there need to be different strategies. And like Peggy said, I think the most important thing here is really the economic incentive, because ultimately any mass timber producer will want to keep producing mass timber. That's the economic incentive. And so they will not deforest because it goes completely against what their interest is. Now,
Right, they need that feedstock.
yeah,
Yeah,
exactly.
absolutely.
And
Right.
then, but the tricky thing right now, especially with climate change, is that forests are a long-term investment, so to speak, if you want to think of it that way. The trees take whatever 80 years to harvest, to be up to harvestable sizes, putting it that way. And so it's an interesting time right now where they have to start thinking about, well, what will live well in 80 years.
Mm-hmm.
So
Well, it
it's a
does seem I see some parallels to the energy challenges we face as a region. I mean, I think it's worth calling out that we're not necessarily talking, right, about new massive efforts to either encourage or harvest uh, species in Massachusetts necessarily for MT production, but perhaps there's a regional approach where um, that harvesting is happening in Maine or states that just have far larger resources, and maybe the manufacturing is happening in Maine as well, or in other New England states, or perhaps in Massachusetts. In the same way that we're looking to, the waters off the shore of Massachusetts to as an amazing offshore wind resource, and the way that we look to inland Maine as an incredible land-based wind resource. And maybe we can get into this a bit more when we talk about the economic development piece, but it does seem like there's a regional approach here that that makes sense, and we're not necessarily talking about having all the components of this industry concentrated in one state or another.
I would
Yeah.
agree with that. There are not only forest differences, but there are cultural differences. On the West Coast, the forestry aspect is huge. It's already very much alive and giving people jobs, whereas here, a lot of the mills have closed down, and what we used to have as a vibrant furniture industry is no longer. So we, it would be nice to get back to that proud use of our forests in like covered bridges, those heritage bridges is that you now see. But even like from the um, wanting to get into our forests and actually use some of these species that are lesser known species for structural purposes, there's not that mm, drive like it would be on the West Coast. So there's cultural differences ultimately. So those things have to be considered absolutely for
Yeah,
the people.
absolutely. And this may be a good pivot then to the kind of economic development piece.
Hmm.
I know that, you were kind of just getting at this, right, Peggy, that mills once dotted the landscape across this state and all of New England, and far fewer remain. And I know that the Healy administration has a very strong interest in supporting rural economic development, and the Energy and Environmental Affairs is very interested in the forest economy. So, do you see, and again, we were kind of getting to this a little bit, but does mass timber represent an opportunity for rural economic development in Massachusetts and beyond? And what does that look like?
That's a big question, and unfortunately, a kind of a long-winded answer, if you kind of indulge me for a minute. I would say yes, but on the surface, there are many reasons why we would want to have a plant here in the Northeast region. I'll just maybe list the reasons why it makes total sense, and then maybe tell you why it's not happening, at least from my own perspective.
Great.
So the Northeast is a construction hotspot, with cities like Boston and New York right next door. It would put mass timber closer to those markets. Of course, that would reduce transportation costs and emissions, but I think there's a really strong desire for architects to be able to say we buy local. Our trees come from our own backyards, or not backyards, but our own wood baskets.
Mm.
Right now, as we mentioned earlier, the mass timber comes from the Pacific Northwest, the Southeast, Canada, even Europe. So it would be great because Boston and New York have that construction boom happening. The Northeast has some severely economically depressed regions in northern Maine and even in western Massachusetts, all Vermont and New Hampshire, that would very much benefit from jobs that would come with a mass timber industry, like all the way from um, upstream and to downstream of the supply chain. Um, Foresters, tree planters, truck drivers, mill workers, mill managers, delivery folks, logistics folks. I mean, a lot of jobs. Some of them are skilled, some of them not so skilled. So it really presents this wonderful opportunity to try and reinvigorate that forest economy again, like it used to be in the 50s for furniture, as I say. And this mass timber industry is really high tech manufacturing wise. Like it uses robotics and highly mechanized equipment that right now mass timber manufacturers in North America buy the equipment from Germany, France, Switzerland. The really high tech stuff comes from Europe. So I would even say that Mass Robotics Hub, we have the expertise here to really jump on that bandwagon and be part of that high-tech wood processing industry. So it presents these really exciting opportunities.
I hear echoes, just sorry to interrupt, but I
Yeah,
hear echoes of kind of this similar challenges with regard to offshore wind. You know,
yeah,
we actually have a lot of the skills and the
yeah,
abilities to manufacture, to build up an offshore wind supply chain, and we're beginning to take those steps, and
yeah,
MassCEC supports some of that work, but a lot of that product is coming from Europe right now, and
right.
it's an enormous opportunity for us to build more of that here.
Absolutely. Exactly right. And the other point about why we would, at least on the surface, want to have plant is that the East Coast is one of the most heavily forested regions in the US. Um, that comes with the caveat that we have a very heavily mixed species forest region, and a lot of them are hardwood, which are not necessarily ideal for structural purposes. They're not being used in mass timber. It's why we have such beautiful colors in the fall, the birch and maples, but they don't unfortunately make great wood for mass timber. Um, Most of the structural lumber that we produce here, I think you alluded to this earlier, Galen, comes from northern Maine. That's spruce, pine, and fir. And there are mills, operational mills up there who are producing it and using it for stick frame. And in fact, just recently for cross-laminated timber by Sterling Structural, who also adopted Eastern hemlock. One thing I didn't mention at the outset of this, but you did, you alluded to it, that my research um, had looked into the structural viability of using Eastern hemlock in cross-laminated timber, and proved that it's definitely a viable material, and it competes really well with the established grades of CLT. So Sterling Structural, fast forward to today, now has an actual product line using Eastern hemlock. That lumber actually coming from the New England region that is part of their portfolio. You know, so architects can phone them up and say, yes, I want Eastern hemlock for my project in Somerville, which has happened already. So it's kind of cool. So on the surface, it sounds like it would make a lot of sense. And in fact, some um, manufacturers have expressed interest in putting a plant here. Smartlam, a bunch of years back, so they have their headquarters is in Montana, and they have a plant in Alabama, I think it is. And they announced a few years ago that they were going to put a facility in northern Maine, close to some of those larger mills up there, but they never did.
Mhm.
And why not? Well, maybe conjecture on my side, but I think a lot of it has to do with lumber mill competitiveness. Um, the ones that are here now don't have the high-tech equipment that the mills in the West and Canada have. They're not set up for mass timber production. To produce CLT or glulam, they need to have laser scanners and 3D imaging systems and fast stress graders so that you can quickly figure out the grade of the wood, robotics to optimize the
Mhm.
cuts and move material around quickly. So, and sophisticated kilns, because some of our species, like Eastern hemlock, would benefit from a vacuum kiln, as opposed to just the old regular drying kiln, which takes much more time. So, you know, that's a big disadvantage, but maybe it could be overcome with enough investment. The other aspect
That
of
investment will only happen with if there's demand, right? So if
exactly,
there's, yeah, so if you have
exactly,
policy frameworks to further encourage, and we'll get into this a little bit. I mean, the state is doing quite a bit and we are to promote responsible mass timber, but right, these facilities aren't going to make the investments unless they see the demand.
right, you got it. So yeah, we'll get maybe if later I can talk a little bit more about some of the initiatives that are happening to try and increase demand, but focus specifically on production. A lot of our forests around here are privately run, I should say family forests, and
Mhm.
they represent smaller parcelized, like 80 acres of land, and they're owned by families, each with different opinions about what to do with their trees. Like Alex was mentioning, New England Forestry Foundation, they, together with our own UMass Family Forest Research Center, they do an amazing job reaching out to these families and to help them decide whether to harvest or conserve or sell or pass on the land to their heirs. But because there's so many little swatches of land, it really complicates the lumber supply chain and increases like administrative costs, I would imagine, permits and contracts and road access to get in there is complicated. So it just makes it a lot more difficult than what's happening in the West Coast when there's much larger areas that are being harvested by big companies. So um, and the last thing I would say is that the supply chain efficiencies are just not there yet, not like on the in the Pacific Northwest or Southeast even. They
Sure.
have broken down. So um,
And that would just come with larger markets and you'd get economies of scale and right
economies of scale.
consolidation and so on, right? So we're
Exactly
kind of in
right.
the easy to recognize early and somewhat painful stages of market transformation. And that's that's just simply where we are.
Totally.
Um, I do think it is I would like to just briefly recognize, that there are some wonderful leaders in this space. Heather Hendrickson and her team at Harvard have, are the kind of forces behind the Treehouse project at Harvard, which is really exciting.
Hmm.
John Dalzell at the city of Boston has been
Hmm.
pushing on mass timber for a while now, and the city's demonstrated great leadership with regard to mass timber. At the Leggett McCall, I think, just got a lot of attention for their mass timber, pretty significant multifamily affordable housing project in Charlestown. Really beautiful
Hmm.
structure, uh, and um, and there are
I
so
would
many
also,
others.
I
Our
would
very
add.
own, my wonderful colleague Bev Craig just launched our Mass Timber Accelerator here at MassCEC. I believe that was just
Right on.
launched yesterday, actually.
Awesome.
Yeah. So, and at the state, Energy Environmental Affairs is very supportive and working very closely with DCAM, the Division of Capital Asset Management and Maintenance, which is for those of you who don't play bureaucratic acronyms for $500, that is the state body that's responsible for public construction projects. And so they've done a few mass timber projects as well. So there's this wonderful mix of kind of public, private, and academic sector market actors who are, effective early adopters, market leaders, creating some of that market pull. But we're still, as we noted, kind of in the very early stages. Again, really just with these early adopters, and haven't yet reached a point where there's significant market traction, which I think is what we'll need again in order
Mhm.
for facility owners to justify making investments and so on.
Actually,
Uh, yeah.
let me quickly expand, if I can, on the academic side
Please.
and give a shout out to our academic administration at UMass and a bunch of other universities, because a lot of universities are building dorms, academic buildings now in mass timber. There's a bunch of showcase projects out there, and even at UMass, we've seen that our John Oliver building was only the start. There's currently a hybrid mass timber building going up, the Sustainable Engineering Laboratory. And the computer science building got expanded with a mass timber wing. So it's very
Great.
exciting actually to see how these projects can then spawn other projects, and people get excited and they want a mass timber building then. And I mean, the other benefit too that we're seeing is uh, we used to have to, in our classes, drag out slides from other places, and now all we need to do is point up. It's like
Exactly.
now it's the teaching part is so much more visceral. It's much more immediate. If engineering, architecture, construction students can see all of this and hear from experts, of course, but also study in these spaces, it's really beneficial for them overall.
And thank you for sharing the beautiful your beautiful background shots, Alex. That's great. We were we were discussing before we all jumped on how this is such a visual topic, and mass timber is it's so warm and so beautiful. So it's really nice to see some images. Thanks for sharing those. I do want to talk a little bit about uh, mass timber and housing. And I'm sure you're both aware, and many folks tuning in today are aware that we're in the midst of a fairly significant state and regional housing challenge. And mass timber has been identified in multiple studies as a really good solution for this kind of middle market 6 to 12 story mid-rise apartment buildings, where my superficial understanding is that it's often too expensive to use steel or concrete in this segment, but those heights prohibit stick-built conventional construction. So, Alex, first of all, is that accurate? And could mass timber be part of the solution in this segment, this kind of mid-rise multifamily housing segment?
Yeah, it's really good that you're switching over to the demand side, like you were saying earlier too, because there needs to be that demand. And actually, just quickly stepping back from your question for one quick, if I may, one quick second. One thing that happened is that the code changes are fairly recent, that allowed mass timber to be built. Um, Again, a few three-letter acronyms, but there's the International Building Code, the IBC, which underlies any kind of state building code, and Massachusetts was on the 2015, I think, IBC for a while, and just recently changed it to the more current version of that includes possibilities for mass timber in a very new and much more exciting way than we used to do. This came up when we were building the over-designed building, because at that point, some parts that we wanted to build were not part of the building code. And so everything's possible if you prove it, but you have to go through this process of proving viability on a single project, and the costs that are associated with that. So that is often too much of a hindrance for project developers to take on a new technology like this. And so having that now in the building code makes a lot of things possible immediately, because it's immediately allowed. There's no process to go through. And pivoting back to your question, of course, that especially when we talk about housing, very often multifamily housing ended up being stick built, that can only be built up to, I think, 5 stories or something like this. And then the typical solution there is to put a story of steel or concrete below that, so that you get a commercial story, and
Right.
you get a little
Pedestal
more
with stick built above it.
exactly
Yeah.
classic construction all over Boston, everywhere.
Mhm.
Hotels, multifamily. That's where that is. And so that fills that side very cost efficiently. But then anything taller than that, and you alluded to this already, classically would be built in steel in our neck of the woods, so to speak. Concrete in other places. West Coast is more concrete. We're more steel here. But it's not as cost efficient. And so that's really where this mass timber can come in, and where these new categories can come in. So just if you indulge me a little bit, just a really quick overview. The new building code allows now 3 more categories. They're called type 4, A, B, and C. And we can build quite high in those categories, up to, I have to to find the numbers, but anyways, but we can do several more stories now beyond this kind of 6-story limit, and so then that middle portion of the market is now permissible right through the code. And then anything taller than that, that's where it gets a little tricky on the mass timber side. There are buildings like the Ascent Tower, for example, which have a number of concrete stories, and then, of course, a number of mass timber stories on top of that, that allow for fairly high construction, but typically at that point you're more in the steel range for us. But like you said, this middle segment can very much be covered by mass timber. There are other benefits too, even for lower rise buildings. Floors, for example, can be fairly efficiently done in mass timber because a lot of walls in these multifamily projects are pre-manufactured, offsite manufactured. They get brought to the site and then lifted in place. And if you can do that with the floor too, everything's a little faster. So that works. Shear walls, elevator walls, basically, elevator shaft walls. Those kind of stair walls and stairwells, that can be done with these new products like cross-laminated timber, even on the lower height side of things. So there's quite a few possibilities now that developers have, and even if they don't do the whole thing out of mass timber, maybe they'll use a hybrid approach with light frame or with a structural steel. So there's a bunch of new possibilities.
Do you mind if I jump in and add one more thing
Please.
here? It actually has a lot to do with our own regional supply of species. Some of them are non-obvious. They have lower specific gravity or density, and they don't make as strong a structural product as the Douglas fir cross-laminated timber or glulam. But if we're specifically talking about housing, and this is an argument I've made to politicians and so on, we are not looking at long spans or high loads. And so we could potentially use CLT or glulam from lower quality species. And it really does lend itself well to commoditizing mass timber more. Sterling Structural, I mentioned earlier, they have CLT up to 17-foot spans. They don't do everything. Like most of the mass timber manufacturers do the 60-foot long CLT that can span multiple supports and can be used in a shear core, elevator, shaft, that kind of thing. Well, they don't. And, I think multi-story family housing can support just short spans, lower quality, and be built beautifully by code. So yeah, I think there's a great argument here to try to get mass timber more into those kind of applications.
Great. Thank you both. That's really helpful. I'm just looking at the time, and I want to use our remaining minutes as strategically as possible. I want to get to some questions. If you could just perhaps, I do want to very quickly hit on, a minute or less. I try to address the federal administration, which has, been very challenging across a broad swath of climate tech products. But I do think it's kind of interesting to think about the tariffs on Canadian products as perhaps an opportunity to slightly improve the economic condition or environment for U.S. produced mass timber. Is that a kind of fair assumption that because of those raw goods from Canada, the stick-built 2x4, 2x6 products are going to be more expensive now? Does that slightly improve the project economics for mass timber manufactured in this country?
I'll start if that's okay, Alex. In terms of raw material for mass timber, the 2x4 lumber, the manufacturers take it from their own regional wood basket. So even companies like Mercer Mass Timber, who have facilities in, I think it's Kelowna or Penticton, BC, and another one somewhere down south, Montana maybe, they have completely different species in those two different facilities because they draw from what's around the mill. So they don't actually import lumber to make mass timber from Canada, unless they have a facility in Canada. So I don't think that very high tariff, is it like 45% now or something outrageous, is going to have an impact on the manufacture
Nobody
of
knows.
nobody knows. But then in terms of engineered wood products, like if a project was being built in Boston, they had to look at Nordic from Northern Canada versus Mercer from Montana, then or Smartlam from Alabama, then there may be a slight advantage to American-made products from that respect. That's possible. But
But
yeah, go ahead.
I was just going to say another aspect is there's also tariffs on steel, and so there might be some opportunity costs happening here, opportunities coming
Sure.
our way.
Great. Well, I do want to make sure that, again, we've got some questions. I suspect I actually have to look. But also, I wanted to give you both an opportunity to kind of talk about, I think we've talked about some of the steps that the state has taken. We're very happy to have just launched our Mass Timber Accelerator here at MassCEC. But what are some other things that the state could do to help improve market conditions, increase market traction for mass timber products? What are your kind of like your top five quick hits on next steps that we could be taking? That could be programs, it could be policy, any of the above. Love to hear from you on that.
I'm going to jump in with a self-serving wish. Research. We really need money to conduct research. Steel and concrete have been the status quo for so long. We've got nothing left to research. But steel, no, I'm kidding, of course. But there's so much opportunity to go in new directions with mass timber. Species is just one thing. New other types of technologies. I didn't really say my other research areas, but we're now looking at mass timber T-beams, different configurations to be more efficient with the use of the wood. Robotics for mass timber production, life cycle assessment, all of these things, we need more people and more research happening in laboratories. Of course, yeah, go ahead, Alex.
I was just going to add education as well, because I
Absolutely.
mean we're trying to do our part, teaching our own students, but there's always been a bit of a lack of education in engineering schools, and constructors often didn't know how to estimate this material, how to build it. So all of that is very much needed, and encourage all the schools to have a mass timber class.
Absolutely. There's actually very few engineering schools with mass timber uh, design at a
Mm.
high enough level being taught in the US. I think around 50% actually offer anything in timber design. So that's a major component of getting people comfortable and more familiar with the material when it's laid out on the job table, which options we're going to go with. It works against wood to not have an expert in the room. So definitely, yeah.
Then
Right. We
maybe
can't, the market pull can't come from developers and building owners and facility owners alone. We need the design and engineering community to kind of come along for the ride and embrace the approaches. And there is software out there, right? I think that there are some companies working on this in Massachusetts, which is very exciting.
That's a great
Um,
point. Yeah.
and maybe one more aspect, and that might answer one of the questions that I'm seeing here, is also, very often if wood is not even considered, then it can't even compete. And so there are places that are going with like a wood first sort of approach, where any project or any publicly funded project or some, what pick your field. Um, uh, at least considers wood. And once people do that, it's actually interesting that the structural cost for a whole project isn't that big overall. The mechanical systems cost far more on a building project. And
mm,
so at that point, it may be a little up, little down, and there might be opportunities that if wood is considered early on in the design process, you can make it very much cost competitive. You may be able to make it cheaper. You most probably are going to be able to speed up your construction schedule overall, and have cost savings that way. And so there's quite a few of those things that can be considered, um, again, if people know, if people, at least consider it.
Yeah. I mean, I think I know we're pretty much at time here, but there are some wonderful questions in the Q&A, and I think what I'd like to try and do is perhaps work with you and post some answers on our Thoughtful Climate website, which we'll have up soon, a page on our website. I just have to share that John Dalzell is hoping we can share the image of the steel beam draped over the mass timber beam, which is, kind of a scary picture appropriate for Halloween, I think.
Yeah,
I
you
think
got
some
it,
good,
John. I'll
okay,
make sure you get it.
some good questions around the credibility of some of the various sustainable forestry associations. I think that's a very good question that I certainly remember from my earliest days in the green building world. Um, and then something that I failed to a question I failed to pose to you, Peggy, about the woolly adelgid and hemlock. So might this help? Maybe perhaps if hemlock becomes more commercially valuable, perhaps there'd be greater efforts to combat woolly adelgid, which is depending on where you are in the region, decimating that species, which is a very important species with regard to ecosystem health.
Definitely. We've got entomologists in our department actually who are looking at other insects that eat the woolly adelgid and ways to try and avoid it. But yes, absolutely, we need more people on that to try and save the good species that we have. And it all
Right.
costs money. Yep.
So perhaps we'll leave you all with that. I want to thank you both. This has, I think, been a really wonderful conversation. Thanks to everyone who joined today. I just dropped, if you're interested in tuning into these series in the future, I just dropped the link to subscribe to Thoughtful Climate in the chat. Next month, we'll be talking about balcony solar and other DIY clean energy approaches. So that's the next topic we'll be covering. But again, I want to thank you both for joining me. This has been a really great conversation. Thanks to everyone who joined remotely, and look forward to the next conversation.
Thanks for having us.
Thanks. Thanks so much. Take care.
Take care, all.